Onward and upward, calculus continues with the analysis of multivariate functions. Now what's a multivariate? What is that? Well, what that means is that we're going to look at functions that have multiple inputs and multiple outputs, and our goal is nothing less than relearning all of calculus for such. Why do we care about that? Well, we care because multivariate functions are really everywhere. In fact, if you look around, you're going to see them all over the place. One of the simplest examples comes from surfaces, graphs of functions with, say, 2 inputs and 1 output. Now, these are simple. They're low-dimensional. You can draw pictures and see what's happening. But that's not all. We're going to see lots of examples of multivariate functions in coordinate systems and coordinate changes, where we're working often not in 2D or 3D, but in arbitrary dimensions. This is going to require us learning so many new tools, but much of what we're going to learn is going to come from one wonderful subject. This is the subject of linear algebra, and we're going to sketch out the basic ideas of it in order to help us do calculus. Now, this makes a lot of sense since so much of calculus involves approximating nonlinear things with linear things. We're going to focus on the mathematics of the linear, starting with vectors and matrices. And we're going to use vectors to encode multiple rates of change of functions. And we're going to use matrices to manipulate those vectors and solve systems of equations. But come on. I mean, so what? Why do we have to do all this stuff? Can't we just skip to the calculus? Besides being a crucial prerequisite, ideas from linear algebra have a life and utility of their own, impacting so much. We're going to see vectors all over the place in machine learning, using dot products for classifying data. And this happens not in 2D or 3D, but in very high dimensional spaces. More generally, when looking at statistics, if you're interested in extracting information from data, maybe you want to find a best fit line, a best fit plane, doing some kind of linear regression, you're going to need linear algebra to do that. But we're also interested in geometry, things like distance, area, volume, and higher dimensional volume. And we're going to use matrices and especially determinants to help us compute volumes in high dimensions. This is going to be super useful when we do integration theory. We're also going to be solving linear systems, large systems of linear equations using matrices and vectors. And this is so useful in so many applications. Now, this is going to be a lot of algebra, and it's going to be a lot of work, but it's also going to be a lot of fun. I hope you are ready. There is so much more for us to see and learn and do.